Algebra 1B, what's up? So today, real simple, we're going to talk about parabolas. Now, this whole video is just to make sure that we wrap everything up, pull everything together, and make sure that we're okay with everything. So I'm going to take it from the top. Hopefully I don't bore too many of you, but I'm going to take it from the top, make sure we're okay with it. So the first thing I want you to understand is those are all quadratic equations. Why are they quadratics? They have an x squared in them. Period. That's what makes quadratic a quadratic. Anytime we graph one of those guys, we get a parabola. Now, what's a parabola? A parabola is this U-shaped curve. It just has a funny name. That's it. Now, these U-shaped curves, we need to understand several things about them. One, they can be facing up, opening up. They can be facing down or opening down. They can be wider, they can be narrower, they can move all around. So we have them moved all over this graph here. That's it. Those are called transformations, which is what we did and what we're going to get back to. Now, a couple parts now that after you've done some of the Khan Academy videos, you might have a little better knowledge of. They all have a maximum or a minimum point. For instance, this guy here that opens down, he has a maximum point right here. This guy here that opens up, he has a minimum point right here. And of course, these guys also, this guy has a minimum point, this guy has a maximum point. All of those purple mins or maxes are what is known as a vertex. That's it. So now, the other thing I want you to understand with all of these is because they're this U shape, they also have an axis of symmetry. Basically what that means is if I draw a vertical line down through that vertex, and I'll do one of the ones that opens down as well, what happens is this side over here, they're symmetrical. It's like a reflection from Algebra 1A. You talk about reflections. If you were to flip this over that line of symmetry, or flip this guy over, that gives you the same exact shape. They're reflections of each other. We use that because the fact that if I pick a point on this side of the parabola, if I go straight to there, the point over here is going to be the same distance apart. Those two segments are going to be the same. It's symmetrical. So we're going to use that to our advantage. Now, so here's what we're going to do. Real simple. First off, I want to explain to you some of the things that Khan talks about on his videos. He talks about finding the vertex. He talks about a max or a min. A lot of the ones he's dealing with look like this. And he keeps referencing back that if you have a maximum or a minimum, he looks right here at the squared part, because the squared part determines that maximum or minimum. How does it do that? Because this squared part right here will always be positive. So that's why you'll see him put underneath this that the smallest value that you can get out of there is 0. So he wants to know when that equals 0. So that's why he keeps saying, all right, x minus 4 equals 0. That means x equals 4. What I've just found out is that the x value of the maximum value on this graph is going to be 4. That's how he finds the vertex. Likewise, if we had something like this, now that I have that -2 in front, I recognize that this here will always be negative. Unless, of course, it turns out to be 0. Like whatever I put in here, I'm going to square it, it's going to be positive, but when I multiply it by -2, boom, negative. The only way it's not negative is when this guy comes out to be 0. So he once again sets x plus 1 equal to 0 and solves and gets x equals -1. That is again the x value of the vertex. Then you can plug that in, find your y value, you can find your vertex. So that's why he references that all the time. So here's what we're going to do. We're going to go back to that exercise that we did way back on March 4th. Here's what you're going to do. I have a document you're going to access. You're going to go to Desmos and you're going to punch them in. You're just going to watch what happens. What we do is we always refer back to this guy. It's the first one that you're going to graph. That is what's known as our parent function. Well, if I can spell parent function. So you're going to graph that first. You're going to take a look at it. Note things, now that you have more working knowledge, note things of, does it open up? Where's its vertex? Note those things, okay? That should be its normal U shape, okay? Then as you go down through 2 through 10, I didn't make it as big as the first one we did, hopefully like our memory kicks in. I want you to take note of, where did it shift to? Did it move left and or right? Is it wider or narrower? And last but not least, is it opening up or down? Okay, so that's all you're going to do. You're going to punch those into Desmos, so you're not even doing the work. Desmos is going to graph them. You're going to then look at it and go, hey, compared to this guy, what happened? So I would always keep this guy on your screen. You can do a bunch of them. I'd always keep him here and say, okay, here's what happened, blah, 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 blah. We're going to reference back to the equation that we're graphing. So suppose the next one was to do this. And you graph that. That's where I want you to notice, hey, it moved here, or it did this. And then say, okay, well, what changed from here to here? Well, I added 2. Well, what was he responsible for? Then you do your next one. Okay, this time he moved here and here. Well, okay, what changed in the equation? What's responsible for that? See if you can summarize all that. That's going to help us once we get back to vertex form. So you're going to access that Google Doc. You're going to punch all those into Desmos, try to come up with a summarization, and then tomorrow we'll talk about that. We'll talk about vertex form, and we'll go from there. See you guys.